Astronomers are trying to gather information about a comet passing Earth. They figured out this object, now named 3I Atlas, was an interstellar visitor.
Imagine staring into the night sky when suddenly something strange passes through our solar system. An object not from here. First, it was Oumuamua, the mysterious visitor that defied explanation. Then came 2I Borisov, another interstellar traveler. And now, scientists are buzzing again because 3I Atlas has revealed something no one expected, an anti-solar tail that bends away from the sun in the wrong direction. But here's the question shaking the world of astronomy. Was Avi Loeb wrong, or has 3I Atlas just opened the door to something even bigger than we imagined? You've probably heard the name Avi Loeb. He's a Harvard astronomer who often makes headlines with bold claims about extraterrestrial technology and interstellar visitors. One of the most controversial topics he's been involved in is the study of mysterious interstellar objects like Oumuamua, and more recently, 3I Atlas. Astronomers have now detected something unusual with 3I Atlas, an anti-solar tail, and it's forcing us to ask whether Loeb's earlier interpretations might not hold up. Let's unpack this carefully, step by step. On August 27, 2025, the Gemini South 8.2-meter telescope in Chile caught sight of something extraordinary. Astronomers using the Gemini Multi-Object Spectrograph, GMOS, aimed their gaze at the interstellar visitor 3I Atlas and discovered a faint but striking teardrop-shaped tail stretching nearly 56,000 kilometers away from the nucleus. Surrounding it was a glowing coma nearly 19,000 kilometers wide, far more extended than the compact glow seen just weeks earlier. These images were taken across multiple spectral bands, from ultraviolet through visible red light, and in every wavelength the same story appeared: a distinct anti-solar tail, pushed outward by solar wind and radiation pressure. This was no ordinary space rock. Soon, space telescopes confirmed what Gemini had hinted at. On August 6, the James Webb Space Telescope detected a colossal plume of carbon dioxide erupting from 3I Atlas. The Spherex Observatory mapped it out to an astonishing 348,000 kilometers, nearly the distance between the Earth and the Moon. The gas production stunned scientists: 130 kilograms per second of CO2, 14 kilograms per second of CO, 6.6 kilograms per second of water vapor. That last number was the shocker. Water, usually the dominant driver in comets, made up only 5% of the activity. 3I Atlas was not behaving like any comet we know. Even stranger, NASA's TESS telescope revealed that 3I/Atlas was already active when it was 6 achromatics from the sun, far too distant for sunlight to trigger water sublimation. Something else, perhaps CO2 or CO ice, was powering its early activity. And then came the size estimate. Spherex data suggested the nucleus, or at least its dense central cloud, was nearly 46 kilometers across. That would make 3I Atlas nearly 1 million times more massive than Borisov. By all odds, we should have detected dozens of smaller objects first. Instead, we found a giant. Its trajectory only deepened the mystery. Rather than cutting across the solar system at a random angle, 3I Atlas travels along the ecliptic plane, the same flat disk where the planets orbit. And the chemistry was no less bizarre. Observations from the Very Large Telescope in Chile detected cyanide and nickel, but no iron. Normally, stellar explosions forge nickel and iron together. Nickel without iron is a strange, unnatural fingerprint, one that has some scientists quietly speculating about non-natural processes. Now, with perihelion approaching on October 29, 2025, the real test is coming. As the sun's heat grows more intense, activity on 3I Atlas will rise. Its gas is streaming into space like confessions under interrogation. Interstellar objects, things that come from outside our solar system, are still incredibly rare discoveries. So far, we've confirmed only 3. Oumuamua in 2017, the long, cigar-shaped mystery rock that Loeb suggested could be alien technology. 2I Borisov in 2019, which looked much more like a classic comet. And now, 3I Atlas, another interstellar visitor that's sparked debates about its behavior. Each one of these objects tells us something about the galaxy beyond our solar system. They're not bound to the sun like asteroids or comets we usually see. Instead, they're passing through on long, hyperbolic orbits. That alone makes them rare treasures for astronomers. Now, Avi Loeb became famous, or infamous, because of his stance on Oumuamua. While most astronomers conclude it was probably a weird natural object, like a fragment of a comet or planet. Loeb argued that its unusual acceleration, lack of a visible tail, and odd shape might point to something artificial. He suggested it could be a kind of solar sail, a piece of alien technology pushed by sunlight. That bold claim captured the media's imagination, but also drew heavy criticism from the scientific community. So when new interstellar visitors like 2I Borisov and 3I Atlas came along, all eyes turned back to Loeb. Would these new objects confirm his suspicions, or prove him wrong?
Here's where things get interesting. 3I Atlas is classified as a comet. It came from interstellar space, swung past the sun, and displayed the kinds of behaviors we'd expect from icy bodies warming up: outgassing, dust production, the formation of a tail. But recently, astronomers noticed something strange: an anti-solar tail. Normally, a comet's tail points away from the sun, driven by solar wind and radiation pressure. But what makes 3I Atlas intriguing is that its tail showed behaviors suggesting it wasn't just reacting to solar wind in the usual way. The anti-solar tail detection means particles were being pushed directly opposite the sun, with unusual symmetry and brightness. So let's break this down. Imagine a comet. The sun heats it up, gas and dust blow off, and radiation pressure pushes that material away from the sun. That gives us the classic sweeping tail. An anti-solar tail, however, looks more like a thin, beam-like extension pointing exactly opposite the sun, almost like a laser pointer in the dark. It's not the wide, fuzzy tail you'd expect. Instead, it can appear sharp, structured, and even extend across millions of kilometers. Astronomers sometimes call these ion tails because charged particles interact with the solar wind differently than dust. And while we've seen them in solar system comets, spotting one in an interstellar comet like 3I Atlas is special. It means 3I Atlas isn't just a boring rock. It's behaving dynamically, shedding material, and giving us clues about its composition. And this is where the debate around Avi Loeb comes back in. When Oumuamua zipped by in 2017, it didn't display a clear tail. Loeb argued this absence supported the alien technology hypothesis because comets normally should outgas and form visible tails. But now, with 3I Atlas, we do see a tail, an anti-solar one in fact, demonstrating that interstellar objects can behave like normal comets. This undercuts Loeb's claim that Oumuamua was special just because it didn't show a tail. Critics argue that the detection of 3I Atlas's tail strengthens the natural explanation. Interstellar visitors come in many forms, but their interstellar objects are diverse. Some may be icy, some rocky, and maybe, just maybe, some artificial.
So the question isn't really, was Loeb wrong, but rather, do we have enough evidence yet to say he was right? And at this point, the answer is still, not really. What the anti-solar tail of 3I Atlas really teaches us is that interstellar comets aren't that different from the comets we see closer to home. They outgas, they form tails, and they respond to solar forces in predictable ways. That's important because it means we can use these visitors as probes of other planetary systems. Every time one passes through, it brings with it chemical fingerprints of where it came from. Studying their tails, whether normal or anti-solar, tells us about the building blocks of planets and other star systems. In that sense, 3I Atlas isn't just a curiosity, it's a messenger from another part of the galaxy, carrying secrets about alien worlds, even if it's not alien technology itself.
Thanks for sticking with me on this deep dive into 3I Atlas and Avi Loeb's controversial ideas. What do you think? Was Loeb wrong? Or was he simply ahead of his time? Let me know in the comments below. And don't forget, if you enjoyed this exploration, subscribe to the channel for more space mysteries, cosmic debates, and discoveries that change how we see the universe. Until next time, keep looking up.